so for this first problem, we know that the mass is 10 kilograms, and there's an initial velocity of 6 meters per second, and the coefficient of sliding friction is 0.2, and they want to know the force necessary to keep it moving constant. Well, first thing I'm going to do is, of course, an F-net statement, or excuse me, a force diagram, and then an F-net statement from it. F-net y equal n minus mg, and is it accelerating in the y direction? No, so that's 0, so n equal mg. F-net x equal F minus fric. Is it accelerating in the x direction? Not initially, not in the first problem, so F equals fric. Fric
I'm at that point right now.
is mu normal. Substituting mg for normal, I get umg. So that's 0.2 times 10 times 10. It's 20 newtons. So the force required to keep it moving constant velocity is 20 newtons. That's part A, right? It's tan fácil, ¿no? Sí, claro que sí. Okay. So now, what changes in the force diagram? Who? F becomes F prime, and it's larger than F was, right?
Your son too.
Don't let him in.
Little Steve.
Right. So, F net x this time is still F prime minus F, but is the acceleration 0 now? No. No, it's some non-zero number. Now, many of you chose to work this part C before B, right? You said, well, I can find the acceleration by finding the change in kinetic energy, solving for the change in velocity, find acceleration, then come back to B. How I would work it is they gave me the change in energy, and I know that a change in energy comes from work. So whatever change in energy was there was equal to the net work done. And so I'm going to say that net work is change in energy. Therefore, work, which is F delta x cosine theta, which is 1, equals the change in work, which is 60. They gave me this as 4, so the net force is 15 newtons.
Still chuckling over that joke, by the way.
Yeah. So F prime equal F net plus F. We found F net then to be 15, plus fric was 20, so F prime has to be 35.
35 to 37.
35.
How'd you get 37?
I got the acceleration times the mass, and it was square root of 48 over 4 times 10. So it's the square root of 48 times 5. 5 square root of 48 over 2. 5 halves, square root of 48.
Okay. So it sounds like it's a rounding issue in the square root of 48 then?
Well, I just typed in square root of 48, and it came out a couple of digits above. But it's not important either way they give it, right? They give me credit for figuring this out, right?
I think so. All right, so that's A, and that's B. And then to find C, the easiest way to find C is, well, if I just found that F net is 15, F net is MA, so A is F net over M, which is 15 over 4. Right? Not 4, 10. So A is 1.5 meters per second squared.
So bossy.
Sí, es tan fácil, ¿no?
Big need to put it on a slope.
Test.
I would love it if this was all we had to do.